For years, Pluto was regarded as little more than an icy relic drifting through the darkness beyond Neptune. When astronomers officially reclassified it as a dwarf planet in 2006, many believed its scientific importance had faded along with its planetary status. Once celebrated as the ninth planet, Pluto suddenly became a distant world that seemed frozen in both time and significance. But that view is rapidly changing. A new generation of observations, combined with the extraordinary capabilities of the James Webb Space Telescope, has transformed Pluto from an overlooked object into one of the most intriguing destinations in our solar system. Instead of revealing a silent, inactive world, the latest data suggest that Pluto may still be evolving beneath its frozen exterior, hiding processes that scientists never expected to find so far from the Sun. What was once dismissed as an icy wasteland now appears to be a world filled with unanswered questions. Beneath its frozen landscape could lie hidden activity capable of reshaping our understanding of planetary evolution and perhaps even expanding the places where life might exist. One feature stands above all the others: Sputnik Planitia, the enormous heart-shaped basin that has become Pluto's most recognizable landmark. This vast plain, composed largely of frozen nitrogen ice, is far more than a beautiful surface feature. Its immense size influences Pluto's balance and rotation, making it one of the most unusual geological structures ever discovered on a dwarf planet. Yet the greatest mystery may lie beneath it. Many planetary scientists believe that deep below Sputnik Planitia's icy crust could exist a hidden ocean of liquid water. Although Pluto orbits nearly 6 billion kilometers from the Sun, heat generated by the slow decay of radioactive elements inside its rocky interior may provide enough energy to prevent parts of that underground ocean from freezing completely. If this interpretation is correct, Pluto is not a frozen world that became inactive billions of years ago. Instead, it may still possess an interior that remains surprisingly dynamic, with heat slowly driving geological changes beneath an ice shell hundreds of kilometers thick. The implications are extraordinary. Liquid water has long been considered one of the essential ingredients for life as we know it. If Pluto truly contains a persistent subsurface ocean, then even one of the coldest known worlds in our solar system may possess an environment where simple biological processes could, in theory, exist. While any potential life would almost certainly differ dramatically from organisms on Earth, the possibility alone forces scientists to rethink where habitable environments might be found. Rather than existing only on warm planets close to their stars, suitable conditions could also develop deep beneath thick layers of ice, protected from the harsh conditions of space. Evidence supporting this idea comes from Pluto's surprisingly young and active surface. During NASA's New Horizons flyby in 2015, researchers observed enormous fractures, mountain ranges, valleys, and ice flows unlike anything expected on a small frozen body. Instead of an ancient landscape preserved for billions of years, Pluto displays signs that parts of its surface have been reshaped relatively recently in geological terms. These features suggest that forces inside the dwarf planet may still be active today, gradually altering its crust through processes scientists are only beginning to understand. Another remarkable characteristic of Pluto is its relationship with its largest moon, Charon. Unlike most planet-moon systems, Pluto and Charon orbit a common center of gravity located in space between them, making them one of the most balanced binary systems in the solar system. This unusual gravitational partnership constantly flexes Pluto's interior. Over immense periods of time, those tidal interactions may generate additional heat beneath the surface, helping maintain the suspected underground ocean and influencing the planet's long-term geological evolution. If such an ocean truly exists, it raises one of the most fascinating questions in planetary science. Could an isolated environment hidden beneath kilometers of ice support microscopic forms of life? Deep below the frozen crust, liquid water would be protected from intense radiation and dramatic temperature swings, creating a stable environment unlike the barren surface above. On Earth, microorganisms survive in some of the harshest environments imaginable, from deep ocean hydrothermal systems to Antarctic ice. Those discoveries have encouraged scientists to consider whether similarly resilient forms of life could exist elsewhere under equally extreme conditions. Although no evidence of life has been found on Pluto, its hidden interior has become one of the most compelling targets in the search for potentially habitable environments beyond Earth. What once seemed impossible is now being explored as a serious scientific question, proving that this distant dwarf planet still has many secrets waiting to be uncovered.